Hello and welcome to the video. In this video we will be looking at flow control for beer faucets, otherwise known as how to get the best pour from your beer taps. I guess the problem here is something that barely needs to be highlighted, but anyone with a kegerator will always be in the pursuit of the perfect pour. What the perfect pour actually is may well vary in opinion, but this guide is designed to get you up and running and able to set things up for your own design. So first things first, the average kegerator will have one regulator serving various numbers of kegs via a split of lines to serve each. The splitting of this CO2 pressure is handled by what is known as a manifold. If the setup is left like this, then each keg will get the same level of pressure and thus carbonation. This will not suit many people who brew various styles of beer that call for different carbonation levels. To combat this, your first port of call should be for secondary regulators, as I have already outlined within this video on my channel already. Check this out if you have not already, but in short these will allow you to set different pressures in either bar or PSI, so that each keg is carbonated to a different level according to your needs for the style. Let's move on now on how to fine-tune the end pour. Often when we think of flow control, we think of this being just on the actual faucet. Various manufacturers have popularized this method, but there are other options, and the trouble is changing the flow at this late point is really only any good for you for very fine tuning, and as such is not the full solution. A fairly good example of this can be found in using a garden hose. When we change the flow with these attachments, this tends to disrupt the flow rather than actually being of help if we intended to collect the water from it, depending exactly on how we adjust it, of course. Let's take apart the flow control element of a faucet and take a closer look. As you can see by design, this is simply blocking flow by narrowing the exit, but this can often make the situation worse when there is the need for more than just slight adjustments, because it really does disrupt the flow more than actually controlling it. It needs to be understood that at the faucet end of your beer's journey you have no line resistance or head pressure, so any turbulence can cause foam to break out of the solution very easily. Going back to our garden hose now just for a moment, if we wish to reduce flow here, then we simply turn the flow down using the tap at the other end. Whereas the situation within a beer dispensing setup is that naturally we want a certain level of carbonation within the keg, but we really need to control that pressure further down the beer line so that by the time it hits our faucet it is already at a pace close to where we need it to be. Beer line length and diameter also has a key role to play here, but it is unrealistic to keep changing this, of course. This is why flow control that is built into the ball lock is the actual ideal answer. The beer is then able to travel along your beer line at a predetermined flow rate, irrespective of the pressure in your keg. Due to the existence of line resistance and head pressure, the flow control turbulence at this end of the journey is far more controlled and forgiving. These are very simple to use. You have a control on the very top of the design here that can be fully open or tweaked to various levels to your preference. Later on in the keg, if you notice a flow control change, then you can adjust again as needed very quickly. You can then use your flow control tab if needed for fine flow control to use it to its best advantage. If your faucets are not flow control versions, then there are also designs out there for flow control for shanks. This particular shank works with either intertap or nucatap. These simply sit between your tower and faucet and operate in a very similar way for final flow control. So as you now know, getting the perfect pour these days is more a case of having the right control methods rather than a beer line length that is supposedly going to be suitable for different beer styles, which really makes the task nigh on impossible if anyone is going to be honest about it. If you would like to join this YouTube channel's Facebook group for further discussion about this or other beer related matters, then please use the links shown on screen now. Please be advised that this group is only open to those that can be mature, friendly and helpful. This now brings this video to a close. If you have any questions, then please let me know via YouTube or Facebook. I do hope that you found this video to be useful, interesting and enjoyable. If appropriate, then please like this video on YouTube, and if you've not done so already, then please subscribe. I regularly post new content. Happy brewing!